All right, folks, we're going to continue talking about plant agriculture, and now we're going to start talking about some of the history that led us into the more environmental initiatives in plant agriculture. We're going to start moving towards sustainability, but first we have to learn about some of our troubled past. So the soil is the great connector of lives, the source and destination of all. Without proper care for it, we can have no life because it feeds us. That was a quote from Wendell Berry. All right. Plants essentially need three basic components to grow: energy, which they gain by absorbing sunlight through chlorophyll in their leaves; the elements carbon, oxygen, and hydrogen for producing sugar, which they gain by absorbing carbon dioxide in the air and water in the soil; and smaller amounts of other elements like nitrogen, phosphorus, and potassium, which they absorb through the soil. During the early exploration of the Great Plains in the United States, basically as we invaded America and made our way westward, the land was found to be unsuitable for European-style agriculture because the ecosystems there were too dry. This area was called the Great American Desert. So the area of the United States from the eastern Rockies through Nebraska is considered shortgrass prairie. All right, so precipitation is lower than the tallgrass prairie to the east, leading to overall shorter plant species. So here's a comparison of the precipitation between the tallgrass prairies to the east. So in this region where we are now, we get the tallgrass prairies. When you walk through them, if you're as short as I am, they are generally taller than I am. Is the sound lagging? I can see the video is really, really lagging, and I'm not sure why. Farmers were encouraged to settle into these arid shortgrass prairies, but they had a really difficult time plowing and turning over the soil in them. Cast iron plows would become stuck and caked with clay, stuck in the thick mat of the prairie grasses. A blacksmith named John Deere invented a polished steel plow that was able to cut through the Midwestern soil, and with further improvements, including gasoline tractors and combine harvesters, this led to the conversion of arid grassland into fields of corn, wheat, and cotton. Bam! We were able to produce. A combination of overhunting and a habitat loss severely diminished the population of gray wolves and eastern coyotes in the Great Plains. Initially, farmers in the Great Plains were very successful, in part due to an unusually wet 10 to 15-year period. Many homesteaders were convinced by a theory called rain follows the plow, which hypothesized that this wet period was actually the result of increased. All right, so they were coming up with their own environmental concepts. Hey, the more we plow, the more rain we get. Woo! Lies. Okay, so in the plains, the staple crop was hard red winter wheat, a producer that was planted in the fall, lay dormant over the winter, and then it's harvested in early summer. So some staple crops, what's produced in large quantities to meet a steady demand, include sugarcane, maize, rice, wheat, dairy, basically milk from cows, potatoes, and sugar beets. The top staple crops worldwide are sugar, wheat, corn, and rice. Just a little FYI. Most of the major world food staples are plants. In an ecological pyramid, only about 10% of the energy in one trophic level will be incorporated into the next. So consuming plants directly is a lot more efficient than raising animals. Now, I personally come from a beef cattle background, so stay with me if you are uncomfortable with where this conversation is going. About 7 to 12 pounds of grain is required to produce a single pound of beef. Millions of acres of short grass prairie in the Midwest were cultivated. with native plants like buffalo grass being replaced. So soil is, as you know from the 221 class, it's a mixture of minerals and partially decomposed organic matter. And I know I'm jumping all around, but I'm going somewhere with all this. I'm giving you all the little pieces of a puzzle. It begins as rock, it's gradually broken down through erosion. Mechanical erosion breaks it down through wind and water. Chemical erosion changes the molecular structure of the soil compounds. It's divided into different layers based on composition, and we call these things horizons. The O horizon is basically partially decomposed matter. We find this in forests. The A horizon is where all of our money is, okay? This topsoil contains a lot of organic matter mixed with some minerals. It's very important. Grasslands have the largest, deepest, most productive A horizon of any other soil. The B horizon is usually an accumulation of organic materials, clay, or anything that basically has been alluviated into them. And the last layer is usually a parent material, which is the bedrock from which the soil was formed. So, kind of coming full circle. In 1929, the stock market crashed and wheat prices fell sharply. Okay, farmers tried to recover their losses by overplanting and increasing crop yields. Okay, so they're like, no, everything's bad. I will plant 3 times as much wheat next year to make up for it. Okay, now think about this for a second. The market has crashed and they have nowhere to sell their wheat. So their answer was, I will plant 3 times as much next year. Does that make sense to you? Now, let's keep talking about this. In 1931, because of that mindset, a record crop of wheat was harvested, which means that there was a crap ton of supply and not as much demand, so the prices continued to fall. In the winter of 1931 to 1932, a drought began that would persist for as long as. So, of course, to add insult to injury, the plains of Oklahoma, Texas, Colorado, and New Mexico experienced 14 dust storms that were so severe that visibility was cut to less than a quarter mile. Okay? And then the following year in 1933, they had 38 severe dust storms. Okay, so the market crashed, everyone overplanted. This is the reign of tilling. Okay, so to plant all this wheat, they're just decimating the landscape, destroying soil structure, destroying soil organic matter. There are no glues to hold anything together. And then there's no rain, so there's no crops going. So you've got a bunch of tilled land with no crops that is dry as a bone. And then you get the worst possible combination of dust storms like ever. You could not have asked for a worse situation. Oh, and the market's crashing and we're in between 2 world wars. Everything's fine. So, erosion from water. Mechanical erosion from rainfall takes 4 forms ranked by severity. Splash erosion basically occurs when soil is thrown by the force of a raindrop impact, as shown in this image. And then, of course, we get sheet erosion, which is the removal of a thin layer of soil from a large area. Rillo erosion happens when water is flowing down a slope and carves small channels into the land, like what's shown here. Those rills eventually turn into gullies, which are much more severe, giant, rapidly flowing water channels, basically, like a bit of trucking. So, back to wind erosion. In arid regions, wind is the major cause of erosion. So, in the Great Plains, they had these crazy dust storms, and they had been using terrible growing practices since the 1800s, and well, late 1700s, really. So this picture actually shows the result of one of the worst storms of the Dust Bowl. It dumped 12 million pounds, 12 million pounds of eroded topsoil on Chicago. 12 million pounds. I just want you to absorb what 12 million pounds of topsoil would even begin to look like. But if you look at this picture, you can see that the only soil held in place was by two random giant bushes of grass. Where this man is standing, you can see feet of topsoil were lost. Now, from what you've learned about the A horizon, that's where all the biological activity is. So this was devastating. This was super devastating. So this was what our wake-up call was. This was the moment in time where everybody was like, wow, something really, 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 really bad just happened, and maybe we should pay attention to it and make some changes. And this is when we started saying, hey, we need to protect our soil because we just lost thousands of years of productivity and we gave it to Chicago. And ultimately, President Franklin Delano Roosevelt he created a soil conservation service that kind of came out of this, and it's called the New Deal. So some of these conservation practices basically came out of this New Deal from Roosevelt's administration. It includes contour plowing, which reduces water erosion by planting crops along the slope of the land rather than straight up and down. Okay, so we're starting to learn to plant with contours. Many important commercial plants are in row crops, meaning that they have to be grown in spaced rows. So the spaces in between become highly vulnerable to erosion. So we started doing strip cropping, where we alternate row crops like corn and cotton with cover crops like oats that completely cover the soil to help minimize soil erosion loss with this. Soil detached from the row crops will be trapped by the. We also learned about terracing, converting steeply sloped land into a series of flattened terraces to help stair step water down to help minimize erosion. Oops. Multi-species riparian buffers, meaning that we're starting with fast-growing trees, moving into slow-growing trees. We're essentially replicating the slow movement from grassland into larger trees as we get closer and closer to a stream. So here's a great example of a farm that was utilizing quite a few of those conservation practices. They had windbreaks, rows of trees to slow down winds coming onto soil, filter strips to help catch any soil particles before they hit riparian areas. Riparian forest buffers and wetland restorations helped mitigate water issues. We created conservation tillage to help people move away from tillage and towards more sustainable farming practices. So, introducing concepts like ridge tilling to slow down water over the landscape. Introducing conservation tillage, where different percentages of residues are left on site. And the best of all of them, introducing no-till, where soils are not tilled and allowed to maintain more of the integrity of biological systems. With conservation tillage, there's less runoff, more, and with no-till, we have the best of all the worlds. I'm going to post this YouTube video of Ray Archuleta talking about no-till on the Canvas page. Highly recommend you watch it. It's amazing. Ultimately, we have a fungal dominant system with better translocation and utilization of nutrients because of no-till. We have better water infiltration with no-till. But the troubles that we have with no-till are we still have issues with planting and how to incorporate lime without tilling, and what to do with old machinery, especially if we're still making payments on it. We also, during the New Deal, planted lots and lots and lots of windbreaks. In response to the Dust Bowl, the Great Plains Shelter Belt was built from 1935 to 1942. We planted 220 million trees. And what's interesting about this is a lot of these trees have reached the end of their life cycle now. And so we see a lot of these shelter belts needing replacement right now at a time where our conservation programs are getting cut. And so I just highly recommend people explain to their representatives how important these conservation programs are and that we don't want to relive the mistakes of our ancestors from the Dust Bowl. So there were also biotic factors that contributed to the Dust Bowl. Like all the other things weren't bad enough already. There were swarms of grasshoppers that descended on the few plants that did survive the dust storms. And because we had killed all of the natural predators, we had massive, crazy, large um, populations of jackrabbits in the plains. We had removed their main predators, coyotes and wolves, and so any plants that we did have left over were getting decimated by grasshoppers and decimated by rabbits. And so what you see here is a large pen of wild jackrabbits that were corralled and killed because they did not have natural predators. And we actually still I'm going to skip through some of the human nutritional needs, but ultimately, the Dust Bowl is one of the worst famine to ever hit the United States. A famine is an extreme scarcity of food resulting in diets deficient in nutrients. I'm going to skip through some of like the nutrition because really, it's not what this class is about, and I'll go on a whole tangent. Hunger map. So, undernutrition is a result of a diet that does not meet an individual's basic energy requirement. Drought is the most common cause of undernourishment and famine, followed by war and natural disasters. Humans also need smaller amounts of micronutrients such as vitamins and minerals. If you are malnourished, you can get things like insufficient protein consumption, resulting in a fluid imbalance in the digestive system. This is a special issue in Ghana. Uh, the sickness The sickness name is derived from a word that means that this is a sickness that older children get when the next baby is born due to a lack of breast milk. So I'm highlighting these things because a lot of people forget that most of the anemia is another condition that results in a decrease in the sorry, I keep trying not to yawn. Decrease in the ability of blood to transport oxygen. It's often caused by malnourishment or in the diet. Iodine can result in goiters, which are enlargements of the gland. So, in the 20th century, as the human population grew, famines were becoming increasingly common, especially in developing countries. India, especially, was on the brink of a massive famine in 1961, and in 1968, a book entitled The Population Bomb predicted that the battle to feed all of humanity is over. In the 1970s, hundreds of millions of people will starve to death in spite of any crash programs embarked upon now. At this late date, nothing can prevent a substantial increase in the world death rate. So that's a little doom and gloom. Today, man. Okay. The, the introduction of intensive artificial breeding of crops and genetic engineering resulted in corn being taken from being a normalized grass to like crazy, crazy large that produce 10 times as much grain as they used to. We increased the use of synthetic fertilizers and pesticides to make monoculture more successful and grow in larger quantities. We also started using the heck out of water. We started irrigating so that if there was another drought, we'd still have access to water deep underneath ground. So the application of water to soil accounts for the largest single share of global water use. Irrigation systems are compared with efficiency, which is a percentage of the amount of water withdrawn that actually makes it to the roots of the target plants. So most irrigation systems are inefficient, with only about 40% of the applied water actually reaching. Furrow irrigation works by delivering large amounts of water through small parallel tunnels that run through the field, shown in this picture. They're about 40 to 60% efficient, meaning 40 to 60% of the water. Drip irrigation uses porous tubes above or below ground that gradually deliver water to the roots of individual plants. They're 90 to 95% efficient, but they're the most expensive and they require a lot of labor. Center pivot irrigation, which is the largest used in the Great Plain region, involves a piece of equipment that rotates around a single point, creating a circle-shaped irrigation field, and it has about 80% efficiency. But what's great about this system is it utilizes a very small percentage of labor while still being decently efficient in terms of delivering water to the plant. And so that's why this became so popular. And I have a gross story about this. So I was at a friend's farm in Nebraska, and they went to turn on their center pivot. And as soon as we turned the water on, you just heard this thunk, 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 thunk. And then, like, a little bit of, like, awful stuff squirted out the end of the water, the head of the irrigation unit right here. And it was, like, red. And all of a sudden, we smelled, like, this awful, awful skunk smell. And immediately we were all like, paper, rock, scissors for who has to do this. Paper, rock, scissors for who has to actually take that apart and get the skunk out of there. Thankfully, I did not draw the short straw, and I didn't have to do it. But yeah, after that, we began to check our equipment before. All right, so large-scale irrigation became available in the Great Plains following the discovery of the Ogallala Aquifer, which is a massive underground reservoir. Indiana, I'm not going to say that we don't irrigate because we actually do have quite a bit of irrigation in the north. But most of the time we're actually draining excess water. Okay, so our water problems are actually we have too much water. Okay, we're draining water from surface horizons into nearby bodies of water via tile drainage systems. This includes any excess nutrients and pesticides, which is where we're having issues, whereas in the Great Plains, they're having issues because of subsidence from sucking dry their aquifers, as well as they're sucking dry their aquifers, which is terrifying. So this may contribute to eutrophication of surface waters nearby. Sorry guys, I don't know what keeps going in the wrong direction, but it's driving me nuts. Okay, so organic fertilizers as sustainable solutions. Great options. However, when mismanaged, they can still cause the same issues that inorganic fertilizers can cause. And there are laws that require the placement of animal manure to include tillage. So we're giving up some conservation measures to apply a conservation measure. Some farmers will minimize the fertilizer they need by using a technique called crop rotation. During 1 year, a nutrient-depleting crop like corn and tobacco will be grown. The following year, they'll grow a legume, which helps create nitrogen by itself. It basically takes nitrogen from the atmosphere using a nitrogen-fixing bacteria, and it creates its own source of nitrogen. Oftentimes, it'll leave nitrogen for the following year's crop. So it's very useful to include in the system. We can also do something called green manuring. Green manuring is where we're growing green manure crops, especially for their organic matter and ability to improve the soil. It can dramatically build up poor and exhausted soils and maintain the fertility of better ones. So you basically will grow a crop, and then you'll cut and either compost it in bins or storage areas, like a concrete pad with tarps, and then you'll spread it over the field in the following year. Or you can knife up next year's crop right into place, that this usually requires killing and cutting the green manure crop. Or you can till the green manure crop into the soil, but it takes at least 30 days before it starts decomposing, and you may not reap the benefits as quickly, plus you are tilling and destroying the structure you built with the crop. So green manuring is a fantastic sustainable alternative that's useful in conventional agriculture. And so if you haven't noticed, we're kind of starting to move into some of the sustainable things that we can do within conventional agriculture. And then next week, we'll talk about some of the cool and fun things that you can do in super, super sustainable agriculture. That's a technical term. No, it's not. All right. Green manure crops. Cereal rye is a great green manure crop. It matures in about 16 to 18 weeks and it yields about 60 pounds per 100 square foot, plus about 4 to 26 pounds of grain. So, in some cases, you can also get a little bit of money. Agriculture mustard. It matures in 6 weeks and yields 180 to 270 pounds per 100 square foot. However, it is invasive and causes all kinds of issues ecologically, so maybe don't do that one. Alfalfa is a legume that fixes nitrogen. It matures in 17 weeks and it can be harvested multiple times during a green season for hay and sold. So, again, you can harvest 1 or 2 of your cuttings and then leave the third to be incorporated as a green manure crop. Um, Banner fava beans are hardy legumes. They fix nitrogen, but they don't do well in cold. They tolerate acidic soils. They mature in 11 to 26 weeks. And they can produce a significant amount of green manure. But there are quite a few people who are fatally allergic to fava beans. So make sure you don't play with these unless you know you're not going to die. More options. Alsike clover, which is the poor soil workhorse, fixes a ton of nitrogen per 100 square foot. Fodder radish has a deep taproot to help break through till pans or glacially compacted soils. A woolly pod vetch is another poor soil workhorse that's very hardy. You can plant it in the fall and it'll survive most winters here. It's less productive than its cousins purple and hairy vetch. But any of the vetches, I will tell you, have to be managed very well. You're going to want to mow them before they flower. Otherwise, they'll take over and you'll never be ready. Ultimately, a lot of these green manure crops can also be used as a cover crop, which is basically a crop that is planted to protect soil over winter. They enhance soil structure by providing more organic matter, which improves aeration and improves aggregation and improves infiltration, and it increases the ability of the soil to buffer pH so that it doesn't leach cations and become acidic as fast. And it increases soil biota and increases nutrient cycling and improves environmental quality by reducing nitrogen leaching and reducing erosion and reducing runoff. And it improves pest management by suppressing weeds and suppressing pathogens and suppressing nematodes. So cover crops have a multitude of benefits to the farmer. Um, the trouble with cover crops in this region, especially, is that we tend to our frost date is October 15th, and generally speaking, our our time of harvest is based on when we're able to plant. And because we usually have late rains um, or late winter, we tend to not be able to get things in the ground, and it causes us to harvest, depending on soybeans or corn, anywhere from September through the beginning of October. Now, our frost date is October 15th. If you're going to plant a cover crop, that means you need to be planting it sometime between August and October 15th if you're lucky and have a late winter start. Ultimately, you need everything planted by September 15th. You can plant as late as October 15th, but that doesn't give it much time to get established because you need time for your cover crop to actually grow and get set into the soil to protect it and provide all of these benefits. However, not all is lost because even if you can't get it into the ground, as long as it's a winter hardy, even if you can't get it into the ground until late, as long as it's a winter hardy seed, it will at least grow the first part of spring while the snow is melting and provide some surface structure and some surface protection until planting season starts. Like clover, hairy vetch are shown here. Clover is so pretty, but the clover shown here is a spring clover, and usually we don't plant this one. Although I did see some this year. It's pretty amazing. Increased nitrogen availability comes from legume cover crops. It also provides wildlife habitat during winter as well as spring, not to mention a food source. It provides erosion control. It increases organic matter. It decreases leaching. And we have considered ways to actually get or cover crops planted while the crop is still standing. There's this really cool uh, newer cover cropping technique that uses a high voice seeder that's really, it's basically a tractor with super tall wheels. And the wheels are so tall that you can basically drive over a corn crop and drop the cover crop seed in so that it starts establishing before you even harvest. And so that's been a game changer for the industry, really allowing us to up our sustainability game. I'm going to post this video on this slide by Ray Archuleta. He's phenomenal. This is a must watch, but I will post it on the Canvas page for you all, okay? All right, so cover crop type actually matters, okay? The depth of the root and the time at which the plant actually grows is really important to understand, okay? So there's actually diagrams that you can get from your local Natural Resources Conservation Service or NRCS office, which is essentially the service that was created by Roosevelt's New Deal in the 30s. They have all the information you could ever want, including where to buy seeds, how much they are, how much you should plant, when's the last possible date that you can plant each type of cultivar, which cultivars work in this area and which don't. Lots of cool things, including, and this is very important because cover crops during the growing season become a weed. Okay, so cover crop is fantastic at protecting things over winter and early spring, but when it comes time for us to plant, we don't want them there anymore. So farmers ultimately spray them and kill them and then plant into those areas. So there's also information on how to control them so that they don't cause issues down the way. So winter cover crops essentially can be used to limit winter losses of unused nutrients. So here's another idea, right? So we harvest and there's excess nutrients there that could be washed away during winter months. Well, what cover crops do is they grow and they suck those excess nutrients up into their little tissues and then they freeze over winter. And then at the beginning of spring, do you know what they do? They go ahead and die and release those nutrients for future crops. Isn't that great? You basically just protected your resources and kept them from washing down the drain. So, of course, this is a fantastic and sustainable. Oh, come on. All of these. Ugh, we're gonna start by talking about. I give up on PowerPoint.